So today we're actually going to see how to implement the AI we did on the previous series to this series with a few changes, and we're also going to see a request that was made in a comment on how to make the camera follow the players and all that. And we're also going to see if the characters go raise their distance, okay, then the camera will zoom out and all stuff like that. And you can see that it's pretty hard. And we're also going to see how to make the AI make combos. I don't remember if I actually have implemented that on the previous video, but what I'm going to keep to not implement is the blocking, because I forgot to make a sprite for it. But we're going to see the code and I'm just going to comment it out. Okay, so let's start. First off, we're going to need an AI character script, a new script, and let's actually come and watch it. Now I just took the one I had on the previous video and I just did the changes, but we're going to see all the differences we're going to add. Now we need a reference to our state manager, which is the new state manager we created on the previous parts, and we also need a reference to the enemy state manager. Okay, on the previous series we had a different name. Now, change state tolerance is how close we consider to be. We basically have two AI states, one for close combat and one when the enemy is at a distance from us. Okay, so how close the character needs to be considered for close combat. How fast will his AI decide state will cycle on the normal state, and how fast on the close state. Okay, for how long it will block, and how much time does it take to reset the AI state. Now I'm using timers over here, but you could just do them with coroutines. I usually do not include coroutines on cases that it might get interrupted, because the coroutine is basically going to run until it ends. Okay, that is why, because I prefer on some cases to use timers. The AI state life, it's how much time does it take to reset the actual AI state. If we have initiate the AI, if we have an AI state to run, and if we are in close combat. Okay, the variables we're going to need. Okay, got random, so random. You can see what it says over here. The variables we're going to need for blocking, and how many times we will attack. Okay, which to randomize the attack, the number of attacks we're going to do, and the current number of attacks, and a few variables for the jump state. Now, the new thing we're going to add is the attack patterns, and to initialize this as an array or a list, but I think we're not going to use a list. An array works just fine, since we're not adding or removing stuff like that. So the class attack patterns will have, basically for each attack pattern will have an attack base which says an attack, an array of attacks. So we have boolean attack 1, attack 2, and the delay. And what this does is I can go into my prefabs, my fighter objects or whatever. Okay, and on attack patterns I can have different attack patterns the AI is going to follow. So for instance, a single attack will only have one attack inside the first element. Okay, and what I want to do is enable the attack 1 button, and if you remember, we go into the state manager, and whenever this is enabled, then the handle animation will enable the the animation, and that animation is going to trigger the open damage collider, and pretty much stuff snowball after that. Okay, and we open the damage collider, and that's why we made the state manager in the first place. Okay, so basically what we say we want to do into our AI is say when we want to open an attack in the state manager. Okay, and this is a pretty cool system, I believe. Okay, so with that in mind, okay, basically it says attack 1 and attack 2. If I want to have them all, both, that means that the AI player hits both attack buttons at the same time, or if you want to have more than 2 attacks, okay, or you can have a pretty much combo system, and you can expand a lot more on it. For instance, you can, instead of just keeping the attacks, you can get percentages inside the elements and basically decide based on percentages instead of randomly selecting an attack pattern. So the second attack is a combo pattern, an example, and what it does, it says hit the attack 1 button and keep it for 0.1 seconds. Of course you can change that to whatever you want it to be. Okay, but keep in mind that to do the combo you basically need to be inside to not delay it that much before the transition runs out. So with that in mind, when the attack 1 stops being pressed, you can hit the attack 2 for the delay, and it's going to go. The attack 1 is going to transition to this animation. The attack 2, before it passes back to the locomotion state, will transition to punch B, and then attack 1 again to transition to the kick, and of course it will return back. So this way you basically keep the combos, do combos, and since everything is based on the animator, even if one of these combos fails, it's just going to make him play an animation which is in turn is going to revert back to locomotion state. So as far as the player concerns, the one that he's actually watching the AI, then it's not going to see an error. It's just going to think that it's a pattern for the AI. So let's get back into our script. This is how we initialize the attack base and attack patterns. So let's close that and let's get back to our variables. Okay, just a simple array. We have an enum for our AI state, close state, normal state, and reset AI, and we declare the AI state by this variable. On start, we get, previously we have named that player controls, but since we do not have any more player controls, we can simply delete that. On states, we can use get component state manager. Now, update. We need to do 3 checks. One that checks the distance, since we based on AI upon the distance. One that controls our states, and one that is our actual AI. So, states. Depending on the state the AI is, it calls the correct function. But there are a few states that do not go into the normal AI state cycle. Okay, and that is blocking, which I've commented out because I do not have a blocking animation. I can enable it, but we're not going to see an animation for him to block, so we're just going to keep hitting him without watching any indication that the character blocking. Instead, just going to not have a heal yeah, it's not going to be losing health. And the jumping, because we want to be reactive to the character. So for instance, if your character jumps, then we want to have a percentage that the enemy will also jump to meet the player's jump. Of course, you can tweak that, or you want the character to actually attack the player with jumping on the air anyway. Okay, or if the player does a special attack or a ranged attack, you might want to have your AI actually jump that. Of course, that is balancing all this is a big deal, and of course that's something you have to think of when you implement stuff like this. So that is our states, and let's see our AI agent. Now, if we have initiate an AI, so we decided has made a full run, as you can see in my comments, and that's why comments are pretty helpful. Okay, we want to change the AI state to the reset AI. We need to create a multiplier, and we also need to return a random value. Random value, return random, is basically a function we have over here, and what it does is basically returns, since we're going to be using this a lot, random.range between 0 and 100, we can simply encapsulate it into a float. Okay, so whenever we want a random value between 0 and 100, we can call the return random. Okay, got random. You have stored the random reference, not over here, over here. You have stored the random reference, and you return it to true. And yeah, because we do not want this to update every frame. Now, if we are not in close combat, we have 30% chances of moving, and we do that to our multiplier. If we have if we are in close combat, then we have 30% more chances to attack. Okay, so we subtract from the multiplier. Now we compare a random value with the added modifiers. Basically, we go randomly what attack. Basically, we decide the AI's behavior by randomly taking a few variables and affecting the multipliers to decide what we want to do. Okay, so we have our random value we get when we add the multipliers, which can be also a penalty instead of a bonus. And if it's lower than 50, then we call the function that is for attack, else we call the function that is for movement. So in our attack logic, we still need a random value, and we do this over here once again. Now there is a 75% chances of doing a normal attack, and we basically, I've commented this out because I do not have the special attack as I said, but let's see it anyway. We have 75% chances of doing a normal attack or doing a special one. Now special ones, basically it is going to make the character play the animation that is for a special attack and make a projectile or something like that. Okay, currently there is no logic for it, so I just have everything commented out. So if you haven't yet randomized the attack, we want to know how many times the AI is going to actually attack. We do that by getting a random value between 1 and 4, and we do 1 because we also want him to attack at least 1. Okay, so we have stored the randomized attack, and then we say if our current number of attacks is lower than the numbers we want to attack, then we decide at random what pattern we're going to use, and this is where you can actually add more logic for percentages, as I said before. Okay, so we get a random value between 0 and all the attack patterns we have. Okay, and then we start the coroutine, which is called open attack, and we assign the attack patterns, and this is, I think this is the delay, or no, this is the index on the for the arrays inside the attack patterns, and then we add on to our current number attacks. So let's see the open attack coroutine, which is this one. So this coroutine will take an attack pattern and an index, which we're going to call I, for the array inside our attack patterns. We start the index with the I, and we want to have a delay. We assign it from the attacks inside the attack patterns, and we say attack 1 will be everything we set it up into our actual attack. So if this is true in the if we set it up true in the inspector, it's going to make the attack 1 true. Same for the attack 2, the second attack. We wait for the delay we actually added from the inspector, so that is, I've set it to 0.1. Okay, and after that we simply disable them. Now, if our attack pattern says that there is more attacks to do inside its array, keep in mind that the length is always +1, so we simply subtract from 1. Okay, we add to the index and we call the coroutine. So we call this coroutine once again by using the new index. Okay, and it will cycle until it plays all the combo it has to do. So let's go back. We saw the attack. Let's see the movement. We still need to take a random value. Now there's 9% chance of moving closer to the enemy. Of course you can change that. You can change that chances based on how much health you have, if you want your AI to be more defensive or more aggressive, and all this stuff. But let's just keep it at 9% for our case now. Now we check if the enemy AI state manager, well, basically because we have the references, we want to simply take its transform for our enemy, and we check its position on the X. If it's lower than our own X, then we say to our states that we want to move on horizontal -1 else, or horizontal +1. So that in turn, the AI character basically replaces the input handler. Okay, so when the input handler, when you have an actual user that presses the left key, it goes to the state manager and changes the horizontal to -1. Now, instead of having a user pressing the left key, we do it this way. And how you decide that you want to go to the left, your character is towards to the left. Okay, it's very simple. I don't think it could be any simpler than this. Okay. Now, if there's a chance that we do not want to move closer to the enemy, then we just simply reverse the order. And that is the movement. And we have, let's see where we call the movement. States, check distance. Now, close state, which we have inside our states. and normal state and reset AI and all that, and we also have it over here. So close state, we simply add to the timer and say if the timer is greater than our close rate, then we reset, we have initiated the AI, and it comes over here, or not over here, into its individual of these things, or not, into the AI agent, and resets all this. Okay, so basically the attacks come over here and say keep adding until you have, until the close state, it's time to close the state. So reset the AI, we add to the AI timer, and if the AI timer is greater than the AI state life, we have the initiate AI false, we reset everything, we reset the code random to false, and there's also a chance of switching the AI state from normal to close so that we get a bit more randomness. So we basically randomly select a state between normal state and closed state, so the next AI state we're going to decide, and we set the current number of attacks to be at 1. Remember, because we always, if it's a time to attack, we always want to actually either attack, we always want to attack if there is a chance to attack. Okay, and we reset the randomized attacks. Check distance, take the distance between our position and the enemy's transfer position, and the distance, if it's lower than change state tolerance, then we simply, if we are not on the reset AI, then we set it to close state. Okay, and we say close combat is true. If it's greater than our state tolerance, if we're not in reset AI, we change it to normal state. But if we are still in close combat, then we want to move away. We still need to get a random value, and there is a 60% chances that our agent will actually follow the enemy instead of moving away. And we're probably no longer in close combat. Blocking, even though we have not yet enabled it. Now, if we are about to receive damage, then we get a random value, and there's 50% chances of actually blocking the hit. Okay, turning the blocking to on, so that will make the stage getting hit to false. If we are blocking, then we want to start counting to stop the blocking. Okay, and we do that over here. And of course, here you can add a lot more modifiers on either to open or close the AI. So basically, it's pretty much all statistics based. Normal state, closed state, and yeah, either it's normal state or closed state, we just simply holds the timers for each state, and when it's over the timer, so the character stayed on that time for the rate we have, then it says that we finished the AI cycle. And lastly, it will be the jumping function, the jumping AI state. So if the player jumps, or we want to jump, we change the vertical from the state manager to 1, and we say jump false. If we wanted to jump, we do not want to keep jumping, but we still need to on else. We need to reset the vertical so that we are not actually stay jumping. We add on the timer to our jump timer, and we keep the jump timer that, and we say we basically control how much the jump rate is going to be, how far you're going to jump. And the jump rate is also a random value, and there's also 50% chances of jumping or not. Now, basically what we can do over here, instead of doing directly this, if we say jump, or I should delete that. If we say jump, we can add this into its own if statement. Okay, and we can get a random value, return random, and check if that random value is lower than 50, then jump. And this needs something. Yeah, it's a float, so that means we either use a float or make it into an integer. So this way the character will have 50% chances of either jumping or not when the other player jumps. Okay, and there's also another chance over here, so we basically have two chances. But anyway, and this should probably be stored somewhere, so you're not actually always jumping. So let's use this. No, let's just keep it over here. Let's leave it over here, and we'll see. Although to test it, we have to actually run everything else. So this is actually what basically the whole AI for our system. Of course, this is just more of an example, or even though you can see you can use it, and it's pretty bare bones, but you can of course expand it to whatever you need. Now let's see the other changes to actually enable a character with an AI. Of course, that means that all your character prefabs need to have an AI character component, and each one can have their own attack patterns, but you might not even this way you can have characters with different AI attack patterns. Okay, so the other thing that you need to check is that your AI character is actually disabled. The same way we have our input handler disabled when we create the characters, we also need to have our AI character disabled. So with that in mind, let's go into our character manager, and we've added a new function that returns the opposite player and not the player we currently have. And you can guess where we use that. So we pass our character, our own character, into this function, and it checks for into our player list for a player base that is not the one we are passing, so it's not ours, and returns that. Now for 2 players this works as it should. For more players you need to do something different, but if you have more than 2 players, then you do not have to worry about making your characters face each other, or your AI should have a different way of deciding what character to attack. Okay, so we use this function into, or better yet, we do not use this function yet. We go into our level manager, and where we actually create our characters, if you remember over here. Okay, which is a human character, an actual user, we need to add another check. So if it's an AI character, what to do? So if the player type is an AI, then you can come over here and say get the component of AI character and enable it. And since the AI state needs to have an actual enemy to work, then here's where we call the new function we created into our character manager. Okay, we call character manager and then we say return the opposite player, platter or player, or whatever. Okay, return the opposite platter, and we pass the character manager players I player states. Okay, and this is how we assign it. Let's see. Yeah. So that basically creates your initializes and makes your character have an AI. Okay, now let's see the work we have to do for the camera. We're going to see two types of both for orthographic and perspective cameras. Okay, and we're actually going to control which one to use by using by enabling or disabling the other. Your game will only have one. So just when you duplicate the camera, since you probably have it on ortho, just make sure to have on your cameras the main camera tag. Okay, now the difference between an orthographic and a perspective camera into the code we're going to see is that an orthographic camera, as you might already know, is it doesn't matter how far back I'll place the camera, it will always have the things all flat out. But the perspective camera makes a bit difference. So instead of changing, if we have a perspective camera, instead of changing the size, since there is not really a size to change, okay, we're going to be pulling the camera back, and we do not have to assign anything else on a camera or a camera holder, but we need to assign on our level manager, we need to assign the camera holder, so which one we're going to use. Okay, so let's see the new script we're going to create, which is going to be called camera manager, and this is what controls the cameras. We need a list of players. Okay, the first one will be player 1 and the other one to be player 2, of course. Now, why a list? There's no particular reason, since we only have 2 players, but if you want to have more than 2 players, you can use, instead of breaking them apart for player 1 and player 2, you can break it up, and you can actually create a middle point between all your players. So even if you have 5 players, your camera will try and follow the middle point between all of them, and you can actually create another transform. So in cases like Super Smash Bros, if you've noticed that the camera isn't always following the players, but there might be some chances that the camera is actually influenced by the center of the level. So if your players are at a closer point, let's say they are going to the left, your camera will have also in focus the center of the level. Okay, and that of course is an extreme case. For a 2D fighting game, you do not usually, especially for 2 players, you do not usually see that. So moving on, okay, the 2 variables we're going to break our players, and vector 3, the middle point, we're going to make our camera follow the middle point. Our variables where we control how the minimum and the maximum the orthographic size can be, or if we have a perspective camera, we can have the target Z and the minimum and maximum Z. Now keep in mind this should be negative, and the actual values I'm using is minus let's see it on the, it's -3 and -7 and 1 and 3. A reference to our camera and our camera type, if it's orthographic or perspective. Now on start we find the main camera, and that is why you need to assign the main camera tag, and we know that the parent, the camera holder, will always be the parent of the camera, and we find the camera type, if it's orthographic or perspective, we assign it by checking the camera. If it's orthographic, then it's going to assign the type of ortho or the type of perspective. On fixed update, we need to find the distance between the first player and the second player. So we say we find the distance, but we also need to find the middle point. To find the middle point, we get the distance and we subdivide by half. Okay, then we basically have the middle point of the distance. So that means on the direction between player 1 and player 2, or player 1 and player 2, if we normalize that and we multiply that by the half the distance, that means we get the middle point. Okay, simple vector math. Since this though is normalized direction, that means we also need to apply the wall position of the player, and that is why after we find the middle point, we also add the wall position of the first player. Okay, and we have the actual middle point. So depending on what type of camera we use, we have our orthographic size, we have a base value which I use 2, and I multiply that by a half distance subdivided by 2. So basically, because I want it to be a little it would not be that fast in changing the size of the camera. Okay, so you can change that depending on how fast or how slow you want it to have. Okay, it's just an offset over here. So depending on the distance, it's going to either raise the size or lower it. And we check if the orthographic size is greater than the maximum of the orthographic, than the maximum that we allow, then we hardcode to be the maximum. If it's lower, then we hardcode it to be the minimum. Now on perspective, on the perspective camera, we can't change the size. Okay, since the perspective camera does not even have a size. So we say the target Z will be -2 multiplied by half subdivided by 2. And it's pretty much the same way that we want it to be a little slower on how you raise the size. It's pretty much the same over here. And then we do, if the absolute value of the target Z is is lower than the absolute value of the minimum we allow, then we hardcode it to be the minimum, and the same way but opposite for the maximum. Okay, if it's greater, then hardcode it to be max. We use the absolute values because we, depending on the way we rotated the camera and depending on the maximum values and the values we have over here, we might need to either make the numbers negative or positive. This way it will not matter what value you have. So finally, we simply need to actually assign the local position. Since we know that 0, the x is always going to be 0, we do not want it to be at exactly ground level, so we just add 0.5 over here, or you can change it to whatever you want, and we simply assign the target Z. Okay, depending on the camera type, we just do something. We either change the size, or we either change the Z of the local position of the camera. So the only thing left to do is assign on the camera holder, assign its position. So we lerp from the camera holder's current position to the middle point of where we find it, the middle point between player 1 and player 2, and all that by time.delta time multiplied by 5. You can change that or make it a public variable and change that from the inspector. We also have the camera manager singleton, since why not? Okay, since you're only going to have one camera manager, you're not going to have more than one, probably. Okay, so we have our camera manager. Let's see the changes we need to do on the state manager, because we probably might have forget that. Yeah, the state manager has some extra. Yeah, it's for the particle system, so we'll see it later. Let's go back to our level manager. So on our level manager, we need a reference to the actual camera manager. We get the instance from the singleton to the camera manager, and on over here what we did, assign the manager. Yeah, this is I think this, yeah, when we create the players, we can also add them into our camera manager. So the camera manager basically has the players and can find the middle point between them. Okay, on the coroutine that creates the players, you can add them. Oops. You can add them over here. So that's just it. Basically, we do not have to do anything else. Okay, so let's see the. Do not forget to add, of course, the camera manager. You can assign the camera holder, but it won't matter because we override this from the script. Okay, so let's see the actual blood particle that we have. Let's drop him over here. Now inside our prefab, where we have our characters, I have a simple particle. Okay, just a particle system, no extra or anything else. But to do the cool thing that makes, you know, the blood particle to see that it counts, you only have to enable the collisions and either set it to 2D or 3D. 2D will interact with 2D characters, 3D will interact with 2D colliders, 3D will interact with 3D colliders, and collides with, you just want to disable the characters, otherwise it's going to collide with the colliders we have over here, and it's not going to look that great. Okay, and I just have one. You can add a lot more up and down and change them depending on the animation it plays, but I think this worked pretty good. Okay, and play with a bit the particle systems. Okay, so basically the bounce, you probably do not want any bounce because blood doesn't bounce. Okay, just assign, apply the prefab basically. And on the state manager, we actually do not assign anything. Let me delete this. Let me save. So on the state manager, we create a new variable to store a blood particle. We only have one particle system, So we simply can use getComponentChildren to get the particle system, and then since the way we set it up, everything, on our function where we check if we're getting damage or not, if we're getting hit, if we actually have a blood particle, then just simply say emit and I'll just use 30. Now of course this is going to depend a lot on your own particle system. Okay, but that's just one more a little detail that I think makes it look cool. So let's see and let's make sure that everything works as it should. Let's hit play and single. Let's select a character, and I think probably everything's going to work as it should. So as you can see, everything looks okay. Now if I want to enable the other camera, I have to just go into the level, disable the orthographic camera and enable the perspective camera. Save, intro, start. I'll select this one, turn 1, and you'll see that we are now on perspective mode. So when we go further back, the camera move back or move to the front. Now I've noticed a few bugs, of course, but that's always expected. So for instance, even if I'm getting hit and jump and I hit, I think, yeah, so when I'm hit and press the up button, the enemy will think that I'm also jumping, so he will try to jump. But as I said, most cases the player will think that that's just a behavior the AI wants to do. And of course, a few changes to the collider might also work better to make it feel great. But anyway, I think I'm content with the state of this project, so I'll end the video over here. You know what to do: like, subscribe and all that. If you like these videos and want to see more, you can support me either on Patreon or by grabbing a project or two from Gumroad, including this project, so we can continue making all this cool content. So I'll see you next time.